Well, learners, I hope you are doing well. I would like to take this opportunity and welcome you in today's lesson. In today's lesson, we're going to discuss in details identification and description of fluvial landform processes. But before we start with identification and description information of fluvial landform processes, I would just like to take this opportunity and ask you to please subscribe to my YouTube channel. Well, let's discuss today's lesson, which is identification, description, and formation of fluvial landform processes. What is it that we are going to cover in this lesson? We are going to discuss about Neander, Oxbow Lake, Sand Island, braided stream, floodplain, natural levee, waterfall, rapids, delta. But as we discuss each and every fluvial landform, we're also going to discuss about how it can be utilized by humans in detail as well. Well, let's start by discussing waterfall. Waterfalls are caused by a difference in rock resistance. If there is a difference in rock resistance, it can cause waterfalls. The river flows over harder rock, and as it reaches the softer rock, it erodes it faster, forming a step in the river. Why does the softer rock erode faster? It's because it has less resistance when it comes to erosion. So it erodes faster. That is why it then forms what? A step in the river. The river flows over this step of what? Of hard rock to form a waterfall. So as you can see in this diagram, you have the hard rock, then you have the softer rock. The softer rock erodes faster because it has less resistance when it comes to erosion. Then now we have what? We have this step there, the overhanging rock of the harder rock. Because it has rock resistance, it takes time to erode. Over time, as time goes on, the overhanging rock resistance, it breaks and falls to the bottom. As you can see, as time goes on, this overhanging hard rock, it then breaks and it falls at the bottom. The movement of this rock in the water, it results in the erosion at the bottom of the waterfall, which then results in a plunge pool. As you can see here, we have the plunge pool. Firstly, we had the overhanging rock, which breaks and falls at the bottom, which forms what? Which forms your plunge pool. Let us now look at significance of waterfall. How the waterfall, how can it be utilized by humans? Waterfalls, they form tourist attractions. Waterfalls can also be used to generate hydroelectricity. Waterfalls also creates an obstacle along the course of the river and makes it impossible to use for navigation and recreational activities such as canoeing. Danger from fast flowing water can result in drowning as well. So we can see the significance of waterfall, especially the issue of that waterfall can attract tourists. For example, in the area of Umalanga, there's an area they call Sabi. Around Sabi, there are some nice waterfalls which generally attract tourists every year. Secondly, let's discuss about rapids. Rapids are areas of very turbulent flow. When we talk about rapids, we are referring to very turbulent flow in the upper course of a river. Where the water flows, over an uneven riverbed caused by rocks of different resistance. So the softer rock is eroded faster, and the harder rock causes the obstruction to the river flow. Why the harder rock causes the obstruction to the river flow is because it takes time to erode. So as you can have a look in this diagram, we can see the river rapids. Remember, your river rapids, it's a very turbulent flow which occurs in the upper course of a river. What is key to understand is what causes the rapids. It is caused by the difference in rock resistance, because you have your softer rock and your hard rock. The softer rock, they erode faster because they have less resistance to erosion. And the harder rock takes time to erode because it's hard, takes time to erode. Then this harder rock then causes what? The obstruction to the flow of the river. Then if you can just have a look at this diagram, you can just see the river rapids. The fast erosion rates, if there's more erosion, it steepens the gradient. Then if the gradient is steeper, the steepness of the gradient, it then speeds up the flow of water. And since now the steepness of the gradient speed the flow of water, causes the water flow to increase the speed, it then increases turbulence, which then create what? Creates rapids, as you can see in this diagram. And significance of rapids, rapids become popular with tourists who want to raft down the stream. Then these features can cause problems with the transport. Ships cannot travel up and down rapids, and it is very hard to build bridges across rapids. They are also extremely dangerous. If people fall into them, they might experience some challenges. Because of what? Because of the turbulent flow that results from. Then now let's discuss about meander. A meander is a curve or a bed found along the course of a river. Just as you can see in this diagram, you can see this is a meander. It's a bend or a curve that is found along the course of a river. It generally occurs in the lower course of a river because it flows slowly and the river begins to wander. The outer bank of the meander is called the undercut slope. As you can see, this is the outside bend, or this is the outer bank of the meander. And it's called what? It's called the undercut slope. And then the inner bend or the inside bend of a meander is called the slip-off slope. Then the meander, it migrates downstream. Then you can see this one is the inner bank of the meander, which is called the slip-off slope. And then this one is the outer bank of the meander, or the outside bend of the meander, which is called the undercut slope. Then as you can see, on the inner bank, the process that is taking place there is deposition. Deposition takes place in the inner bank of the meander. And then in the outer bank of the meander, the process of erosion is taking place. Why? Why do we have deposition in the inner bank and erosion in the outer bank? When there is less water on the inside, there is more friction and slower flowing water, which means inside the bank, the water in this side, the water is flowing very slowly. As the water flows slowly, it results in what? In more deposition. And then in the outside band, the river, it flows faster on the outer bank. As it flows faster, fast flowing water with lots of energy is directed to the outer bank, which then results in what? Which then results in erosion. As you can see, this is a meander. This is how it looks like. You can see there you have the meander neck. Now let's look at the slip-off slope. The slip-off slope, the water is slowly moving on the inner bank, and thus more deposition occurs. Then it forms what? The slip-off slope. It forms a gently convex shape. Then undercut slope, the water flowing more rapidly on the outer bank of the meander, resulting in higher levels of erosion. Then it results in the shape of what? The shape of the slope is concave. The slope is steep because of the erosion that has taken place there. Then oxbow lake. Remember your oxbow lake, it's formed from your meander, which means oxbow lakes form from a meander loop that is cut off from the mainstream. Erosion on the outer bank and deposition on the inner bank of the meander results in the meander neck becoming narrower. Just if you can just have a look in this diagram, since the process of deposition, as the process of deposition and erosion continues to take place, since in the inner bank there's more deposition, and in the outer bank there's more erosion process take place there. It results in the what? It results in the meander neck becoming narrower. During times of flooding, water cannot negotiate the meander loop and flows straight. This then results in the meander loop being cut off from the main river to form an oxbow lake. Let's have a look at this diagram. You can see here, you can see in this diagram we have the meander. This is the meander neck. Since we have the meander neck here, as the process of deposition takes place in the inner bank and the process of erosion takes place in the outer bank, as these two processes continues to happen, it results in what? It results in the meander neck becoming narrow. You can see in this diagram, now here we have the meander neck, it is now narrow. The neck gets narrow because of the process of deposition and erosion. Then it results in the meander neck becoming narrower. Then eventually, during the time of floods, water cannot negotiate the meander loop and flows straight. This results then in the meander loop being cut off from the river to form an oxbow lake. As you can see here, we have now the oxbow lake. Now it's a very nice Oxbow Lake that has been formed. The river cuts through the neck of land during the time of flooding, and then it results in the formation of your Oxbow Lake. Well, now let's move on to floodplain. Floodplain, as the river nears the lower course of the valley, is wider and the gradient is gentle. Then the flat area on either side of the river channel is the flat plain. As you can look in this, this is the flat plain. Under normal conditions, this is the flat plain. You can see the river is flowing nicely there. This diagram, it shows the flat plain. Then during times of flood, the river overflows its banks, depositing alluvium. Hence the name floodplain comes then. As you can see, now it's during the flooding conditions. Now the river has overflows its banks, depositing alluvium. Then now we have the floodplain. You can see the floodplain conditions, which occurs during floods. Floodplain refers to the flat land that is found on the bank of a river. As you can see, this flat land that is found on the bank of the river, we refer to it as your floodplain. It is made up of deposits of silt that has built up after being subjected to repeated flooding. Just have a look in this diagram. You can see this is a floodplain. If you can just have a look in this diagram, you can see that the river is flowing here. But this picture, it shows during the time of flooding. As you can see now, this is the time of flooding. Now let's look at natural levee. Natural levee. During flooding, the coarsest and heaviest material are deposited alongside the river channel, forming a natural ridge or embankment called a levee. Then natural levee, it refers to the natural raised banks of a river. The banks, they are raised during the time of flooding, This forms on the bank of the river that has been subjected to a repeated flooding. Just have a look in this diagram. You see this diagram, it shows natural levee. Initially, it looks like this. Then during time of flooding, there are some heavy materials that are deposited there that forms what? The natural levee, as you can see. And during the time of flooding, you have your coarsest and heaviest materials that are being deposited along the river channel. That forms that ridge. Then after the flooding, water has resided. It leaves behind the gravel, sand, silt, which builds up to form a raised bank, which is referred to as a levee. If you can just, after the flooding, the water level will drop there. As it drops, now we have what? We have the natural levee. This is the materials that were deposited during the times of flooding. So natural levees deposits by repeated flooding. Natural levee, it raises the level of the river higher than of the flood plain. It reduces flooding of the flood plain. Tributaries that flows towards the mainstream are not able to join it because the levee forms an obstacle. And then these tributaries, they then flow parallel to the mainstream and are called Yazoo streams. So if you can just have a look in this diagram, you can see now it will be difficult to have streams, to have tributaries that will join this stream because of the natural levee. Then if these tributaries now they cannot join this stream, now they will have to flow parallel to this stream, which we refer to them as what? As the Yazoo stream. Then now let's discuss about a braided stream. Braided stream forms when a river deposits its load and blocks its own part in which it's flowing, and blocks its own part and is forced to split into smaller channels. Then it forms what? Your braided stream. This feature is formed by a seasonal river that has an abundance of bed load, which is deposited in the lower course. The gentle gradient in the lower course and the decreased river flow during the dry season slows down the river, forcing it to deposit its load within its channel. Then the continued deposition causes sand island to build up on the bed. In this way, the river obstructs its own part. As you can see in this diagram, this is the river, this is the braided channel. Remember, as we've mentioned earlier, that your braided stream is formed when the river deposits its load and block its own part. So because the river deposits the continued deposition, then forms the sand island. So in this way, the river obstructs its own part, you see, because it forms what? It forms the sand island. It obstructs its own part and it branches into smaller channels, as you can see, then branches into smaller channels that weave their way around the deposited material. Then that is your braided stream. Deltas. Deltas, it forms at the point where the river enters the sea and deposit its load. That's where your deltas are formed. They are formed at the point where the river enters the sea to deposit its load. The current of the river keep fine sediments such as clay and silts in suspension. The saline conditions in the sea cause the fine clay particles to flocculate, which simply means that it causes them to stick together, making the particles larger and heavier, which then sink. The deposited materials accumulates to form a delta, as you can see in this diagram. And this is the deposited materials. They accumulate so that it forms what? It forms a delta. Deltas build outward from the coastline, as you can see in this diagram. The deltas, they build outward from the coastline. But will only survive, the deltas, if they form, they will only survive if the ocean currents are not strong enough to remove the sediments. If the ocean currents are not strong enough to remove the sediments, then the deltas will survive. They will only survive if the ocean currents are strong or weak to remove the sediments. If you can just have a look in rivers like Nile, Mississippi, Niger, have very large deltas created, which are used for human settlement and activities such as farming and fishing. Well, today's lesson, I will end here for today. I hope you have enjoyed the lesson. So please subscribe to my YouTube channel.